Today we are going to discuss the test of functional groups, what kind of tests or indications used to identify the different functional groups, starting from alkene. Please give a heading, test of functional groups. Okay, the first one is alkene. Although we have done these reactions when we are doing the reactions of alkenes and all other functional groups, but we're just putting the test reactions only together here in this heading. So, test of functional groups. The reactions which are used to identify the presence of a specific functional group is the test of functional groups. First one is alkene. What is the test? If you suspect the presence of an alkene, add bromine water into that gas or pass the alkene gas through a bromine water. What will be the result if it's bromine? Yes, decolorizes the red brown or orange brown color of the bromines. Please, you have to write quickly. And the reaction that happens, it's a simple addition reaction or bromination in which the double bond breaks and bromine adds up to the 2 carbon. 1,2-dibromoethane is formed. What about the haloalkane? How to identify the haloalkane? Both words used किए जाते हैं. Bromine is either orange brown or red brown in color. How to identify the haloalkanes, bacho? If you suspect this is an haloalkane, this is a bit tricky. Please pay attention. What we do, for example, look at this. If I suspect that this container contains an haloalkane, so what I have to do? I have to add 2 things. Which 2 things? It's actually the combination of वो जो हमने inorganic में भी किया है. You add sodium hydroxide aqueous into a haloalkane and then silver nitrate and then heat them. What do you add? Silver nitrate, sodium hydroxide, aqueous, and heat. What happens? 3 options. Yes, 3 options. White, off-white, and yellow precipitates. If there are white precipitates, they indicate the presence of what? Chlorine. But that confirms only when you add dilute ammonia and the chlorine dissolves. If the off-white precipitates come, that indicate the presence of bromine, but it is confirmed when you add concentrated ammonia. And the yellow precipitates insoluble in both dilute and concentrated ammonia. That indicate the presence of this, right? ये तो test हो गए, but before I let you write this, just look at the chemistry behind it. I'm going to show you with one reaction what is the chemistry behind it. For example, the haloalkane that was inside the container was CH3CH2Cl. What you added? Sodium hydroxide and silver nitrate. By adding sodium hydroxide first, aqueous, nucleophilic substitution reaction takes place, or NaOH ka OH will come and take the place of Cl. और क्या बन जाएगा? CH3CH2OH plus NaCl. So एक तो product alcohol बन गया. What is the product? Alcohol. But the other product, that is NaCl, the silver nitrate which you added later on in a follow-up, that silver nitrate is going to react with NaCl. Now this reaction starts from, I have taken from inorganic chemistry, the haloalkane, the halogens, जिसमें silver nitrate और ये आपस में react करके there is an ion exchange that happens. Why I'm calling ion exchange? इसका negative ion इसके positive ion से, इसका negative ion इसके positive ion से. So they combine like this. What is formed? NaNO3 or AgCl. And AgCl being water insoluble, क्या होता है वो? Appears in the form of white precipitate. And then by dissolving ammonia, how the precipitates are gone? You remember I told you there is a reaction taking place between ammonia and AgCl, और वो Ag के साथ मिलके एक complex बना देता है, which is this AgNH3 twice Cl negative. So this compound becomes water soluble. AgCl was insoluble, but AgNH3 twice Cl is a water soluble. So this is how the whole chemistry takes place in this test of haloalkanes, right? So there's a definite question in this, और इसको relative rate से भी वो connect कर देते हैं. अब ये आपको याद है हमने कहा था कि इसमें किसके precipitate सबसे जल्दी आएंगे? If there is a yellow, off-white or white, which precipitates come early? Yellow, because you see nucleophilic substitution हो रहा है. So iodoalkane will be the one fastest to undergo this. Okay, so वो सबसे तेज होगा. Right, next. Should I move on? Yeah, you have to write all this. Okay, I'll send you this. Okay, but you have any question, please go ahead. Again, I'll explain what happened. Nucleophilic substitution happened in haloalkane with sodium hydroxide aqueous. The Cl comes and takes the place. So NaCl formed, and that NaCl reacts with silver nitrate. This is how you test the presence of haloalkanes. Next functional group था हमारे पास. No, I'll send you. Alcohols. I think I told you when we were doing the reactions of alcohol. There are two tests for alcohols. Adding sodium metal, giving effervescence, indicates the presence of alcohol, but there is a problem. It also gives the same observation with carboxylic acids. So therefore, there are two tests. Number one, add an metal effervescence. This is the reaction, effervescence because of hydrogen gas. But the confirm is PCl5. If you add PCl5 and the steamy fumes are there, that indicates the presence of alcohol, right? So these are the two tests which are used for the presence of alcohol functional group, and these are the two reactions, right? Next come to the aldehydes and ketones. They are the tricky ones, right? So now I would like you to pay attention. Look at this. There is a chemical which is known as 2,4 DNPH. The full name is 2,4-dinitrophenylhydrazine. This is a chemical. Once you add this chemical, and if the suspected compound is either aldehyde or ketone, it's going to give orange precipitates. कौन से precipitates? Orange precipitates, right? So this is for both aldehydes and ketones. This is not for one functional group. So one thing, you have to narrow down your search of the functional group by adding this. You will by adding 2,4-DNPH, if yellow orange precipitates come, that will indicate the presence of either aldehyde or ketone. अब ये reaction क्या? What is the chemistry behind it? फिर आगे जाते हैं वो how to distinguish between aldehyde and ketones. First, let's understand the chemistry. This is the aldehyde. Look at this. Okay, this is the aldehyde. Now 2,4-DNPH, बच्चों, although its structure examiner tell us not to memorize it, but still I'm going to tell you, they give you this structure. Why it is called 2,4-DNPH? Look at this. This is, let's say, carbon number 1. This is 2, this is 3, this is 4, 5, 6. So why you call it 2,4-dinitro? Now you can understand after numbering. There is a nitro at which two positions? 2 and 4. And then this NH and NH2, this part is known as amine, right? So, sorry, hydrazine, not amine, my apologies. Hydrazine. So NH2 is amine, but NH2NH is hydrazine. So what is the name? 2,4-dinitro. This ring is phenyl, hydrazine. But as I said, you are not supposed to learn the structure they will give you. This compound, when you add with an aldehyde, what it happens? It undergoes condensation reaction. Condensation, we learned in esterification. When two molecules join and water is lost, that is known as condensation. So this oxygen and these two hydrogens, they combine to form what? Water. ये oxygen किसका है? Aldehyde का, जो carbonyl वाला oxygen होता है. They combine with this to form water, and this N now going to make a bond with this carbon, और वही double bond ही रहेगा. Okay, so आप कहते हैं this is a straightforward thing here. Double bond किससे बन जाएगा? N के साथ, right? So this is the one. You see, so CH3, rest everything is the same. Just look at this part only. And this thing that is formed, I'm not going to tell you the name of this. This is the one that appears in the form of orange precipitates. Plus क्या बन गया साथ में? H2O. Okay, this is known as condensation reaction. Okay, now if I ask you, okay, the same thing, if I ask you how it's going to happen with ketone, right? So आप कहते हैं the same thing happens with ketone because the reaction that has to take place, 2,4-DNPH has to lose 2 hydrogen, and carbonyl functional group has to lose its oxygen to make water. Now look at this. So if I have a ketone here, for example, here, और मैं इसको 2,4-DNPH दूंगा तो क्या होगा? The 2,4-DNPH के 2 hydrogens इसके एक ऑक्सीजन से कंबाइन करके what they are going to form? H2O. And this ketone is gonna attach with this. Okay, look, यही होगा. And what will be the product? In the product, क्या change आएगा? These H gone, these 2 hydrogen gone, oxygen gone. Carbon is gonna make double bond with. That's it. And that is the thing which have orange precipitates. Look. यही है ना? Plus H2O. इधर देखिए, यही चीज है ना? Is it so? Okay. So this is how the orange precipitates formed by adding 2,4-DNPH in both aldehyde and ketone. What is the active part of aldehyde and ketone that reacts? C double bond O. Okay, right. So ये तो हो गया जो aldehyde, ketones and aldehydes दोनों देते हैं. फिर we need to have some test जो सिर्फ aldehyde देता हो, so we can distinguish between them. There are 2 tests which can be used to distinguish between aldehyde and ketone. Sorry. Or in other words, there are 2 tests which only aldehydes give, not ketones. So they can be used as a distinguishing, right? There are 2 tests which can be used to distinguish an aldehyde from ketone. Number 1, Fehling solution. जो लोग bio पढ़ते हैं, they must know this chemical, Fehling solution. No, sorry, you call it Benedict solution. Yes. So it's a Benedict there. It's a copper sulfate aqueous alkaline. Copper sulfate with blue color का solution होता है. Basically बच्चों जो sugars होती हैं ना, आपको वहाँ reducing non-reducing sugar check करना होता है. Sugars are actually 2 functional groups, either aldehyde or ketone. तो आप यही check कर रहे होते हैं कि वो aldehyde वाली sugar है या ketone वाली sugar है. तो आप डालते हैं Fehling solution. Fehling solution क्या है? Copper. और Fehling solution is actually an oxidizing agent. An oxidizing agent. You know? Or the only difference between aldehyde and ketone is what? The aldehyde position of functional group. And because of that, the aldehyde can undergo oxidation and ketones cannot. This is the difference. So आप कह रहे हैं, you take oxidizing agent, put it in both. Aldehyde will undergo oxidation, but ketone would not. So you can distinguish. This is what we did. वहां भी आप यही करते हैं Benedict solution, right? Okay, you take a copper sulfate aqueous with sodium hydroxide, which is an oxidizing agent known as Fehling solution, and you add in both aldehyde and ketones. Ketones cannot oxidize, so they don't react with Benedict or Fehling solution. So their blue color remains blue. But aldehydes do react because they undergo oxidation. और aldehyde के oxidation से क्या बन जाता है? Carboxylic acid. और उसकी क्या कर देते हैं? Fehling solution की क्या कर देते हैं? इनकी oxidation होती है तो Fehling solution undergoes reduction. उसकी वजह से वो ब्रिक रेड प्रेसिपिटेट्स दे देता है। देखिए, aldehydes give brick red precipitate with Fehling solution, but ketones do not react. I have written the equation here. Look, the aldehyde, इसकी क्या हुई है बच्चों? Oxidation and turned into what? Carboxylic acid. And copper, which is acting as an oxidizing agent, उसकी क्या हुई है? Reduction. Cu plus 2 से किस में change हो गया? Plus 1 में. And this compound is known as copper 1 oxide, and it is a water insoluble and appears in the form of brick red precipitate. So that is the observation. You add Fehling solution, brick red precipitates are there. It's an aldehyde. No brick red precipitates, it's a ketone. And the chemistry behind it, that aldehydes undergo oxidations and ketones cannot. And Fehling solution is an oxidizing agent. Okay? Aldehydes can undergo oxidation, act as reducing agent, hence react with Fehling solution, which is an oxidizing agent, right? Ketones cannot undergo oxidation, hence no reaction with Fehling solution. If you don't have Fehling solution, there is another one that is known as Tollens reagent. That is also an oxidizing agent. And what is this? It is a silver nitrate with ammonia. That was copper sulfate with ammonia. It is ammonia का silver nitrate. यानी silver nitrate में हमने क्या डाला हुआ है? Ammonia. Okay. This is again an oxidizing agent. किससे react करेगा और किससे नहीं करेगा? It's going to react with aldehyde and oxidize it, but will not react with ketone. So when it oxidizes aldehyde, तो Ag positive reduce होके देखिए Ag बन जाता है. तो Ag तो मेटल है, वाटर इनसॉल्युबल है, सिल्वर बन के आ जाता है बाहर. सिल्वर मिरर इसको बोलते हैं, right? So a very white silver appears inside the test tube if you perform this experiment, right? और वो उसकी क्या हो जाती है? Oxidation हो जाती है. I've just written the ionic equation here, not balancing or anything. Just keep in mind. Okay, so aldehydes can undergo oxidation and act as a reducing agent, hence react with Tollens reagent. Ketones cannot undergo oxidation, hence no reaction with Tollens reagent. Yes. उसमें alkali डालनी होती है, but that alkali was sodium hydroxide. Here is ammonia. Okay. और उसमें क्या बना था? Brick red precipitates of copper 1 oxide. और इसमें क्या बना है? Silver precipitates of silver or silver mirror. Okay. So these are the two tests जो ये देते हैं. Right? So aldehyde और ketone के भी टेस्ट हो गए, distinguishing भी हो गए, या in other words you can say aldehyde and ketone ये टेस्ट देते हैं और वो ये देते हैं. Okay? Ketone सिर्फ ये देते हैं. So check करने के लिए अमूमन examiner ask you कि okay we got a chemical, we add 2,4-DNPH, it gives a orange precipitate, so we understand ये क्या है, aldehyde और 2,4-DNPH से दोनों. Then they ask you कि then you take a small sample of that chemical again and place Fehling solution, and brick red precipitates are there, so it means an aldehyde. Yes, or a theory. And if there are no brick red precipitate after 2,4-DNPH, so it's a ketone. Okay. Next, carboxylic acid ka test bhi, I think I told you. There are two tests which are used to identify. One with Na metal. Okay. One with Na metal. Putting Na metal will give effervescence of hydrogen gas. That also common with the alcohol. But the difference jo yahan pe hota hai, that is what? Only carbonate. So the carbonate is the one. If you add a carbonate, the result is what? Effervescence. That is the only specific to carboxylic acids, right? And there are no tests for, yes, they are just fruity smelling liquids is their test or is their identification point, right? So this is how we identify the different functional groups by using the sum of their reactions or one of their reactions that we have learned previously, right? But now one thing, ये तो overall एक हर functional group का अलग test है. एक और test होता है बच्चों, that is called, हम उसे बुलाते हैं iodoform test or triiodomethane. I would like you to write this. Triiodomethane or iodoform test. Triiodomethane or iodoform test. PCl5 or NS metal. Okay, please parents. Triiodomethane or iodoform test. मीथेन और आइडोफॉर्म का फॉर्मूला क्या है? CHI3। अब इसमें क्या होता है कि एड I to aqueous alkaline, मैं एक्सप्लेन करता हूं ये किसके लिए होता है। Add I to aqueous alkaline in a chemical, suspected functional group, यानी I2 plus NaOH aqueous का मिक्सचर आपने ऐड करना है, and what will be the result if it's positive? Yellow PPT. What will be the result? Yellow PPT. और वो yellow PPT किस कंपाउंड के होंगे? CHI3 के, which is known as triiodomethane और iodoform, नाम है दो उसके। ओके, अब ये कौन सा फंक्शनल ग्रुप देता है? Which functional group adding iodine is gonna give the yellow precipitates? किस फंक्शनल ग्रुप की ये आइडेंटिफिकेशन करता है? दिस इज नॉट फॉर वन स्पेसिफिक फंक्शनल ग्रुप, इट हैज 4 डिफरेंट फंक्शनल ग्रुप्स जो आइडेंटिफाई हो सकते हैं। 4 कैसे? देखिए, फॉर एग्जांपल, दिस इज फॉर दीज 2 थिंग्स, लिसन। यानी इफ यू हैव CH3 next to C double bond O in any compound which contains this one, it has a CH3 attached with C double bond O, and you put iodine, it's going to give you the yellow precipitate. So आप सोचते हैं यार ये किस कंपाउंड में हो सकता है? Let's say I put hydrogen here, I assume. तो ये क्या बन जाएगा बच्चों? Hydrogen. It's an aldehyde. And which aldehyde is this precisely? How many carbon? Ethanol. So आप कहते हैं इसका मतलब है कि one of the functional group that gives the test positive is aldehyde, और एल्डिहाइड में भी कौन सा कंपाउंड है जो आयोडीन डालने से येलो प्रेसिपिटेट देता है? यस। अगर, क्योंकि मैं बता ये रहा हूं, अगर मैं फॉर एग्जांपल CH3CH2 C double bond OH कर दूंगा, व्हाट इज दिस कंपाउंड? प्रोपेनल। प्रोपेनल इज नॉट गोना गिव। क्यों? बिकॉज द कंडीशन फॉर दिस टेस्ट इज CH3 नेक्स्ट टू C double bond O होना चाहिए। नाउ C double bond O के नेक्स्ट कौन आ गया है? No, it means aldehyde, ये test positive देता है, and the only one aldehyde, and that is ethanol. Okay, let's move on. I say no, this could be like this. Listen, बच्चों, I'm taking hydrogen off. Let's say I put R group in carbon chain. Okay, let me put CH3 instead of R. It's a ketone now. Right, so it means the other functional group which adding iodine will give yellow precipitate is what? Ketone. And is it like only one compound like aldehyde? Aldehyde में सिर्फ एक ही देता है ना ethanol, और कोई aldehyde नहीं दे रहा था। बट क्या कीटोन में सिर्फ यही कीटोन देगा? प्रोपेनोन? नो, हम कहते हैं even if I replace here with CH2CH3, that's butanone, still it's going to give yellow precipitate. Because CO ka neighbor is still CH3 there. Until you don't change this CH3 and you keep adding group on that side. So it means most of the ketones give. Yeah, in other words, all those ketones jisme CO carbon number 2 pe hoga, they give yellow precipitate. So number 1 functional group was aldehyde, and the only one compound in aldehyde. Ye bhi yaad rakhna hai. And that was no other. Okay, ketone, yes, most of them, but not all of them. Again, most of them but not all of them. Why not all of them? अगर मैं इस साइड पे कीटोन में चेंज कर दूं, let's say I take this ketone next to C double bond O, CH3 won't be the neighbor of CO, so this ketone is not going to go. But most of the ketone से क्या मुराद है? वो ketones जिनमें CH3 is next to C double bond O और number 2 कार्बन पे कार्बोनिल है। कार्बोनिल जब भी number 2 पे होगा, number 1 is obviously क्या है? CH3. So they all ketones, right? Okay, next. दो functional groups हो गए. Other than this one, look, the other group or this one, they also give iodine. आप कहते हैं ये कौन सा है? This is alcohol. If I put hydrogen here, let's say if I put a hydrogen here, तो ये प्राइमरी अल्कोहल बन जाएगी क्योंकि अल्फा कार्बन के साथ 2 हाइड्रोजन है ना, तो इसे प्राइमरी अल्कोहल। और प्राइमरी अल्कोहल में भी कौन सी है ये, व्हाट अल्कोहल इज दिस, एथेनॉल। सो इसका मतलब है अल्कोहल भी आयोडीन डालने से येलो पीपीटी देगा, और प्राइमरी अल्कोहल में आप कह रहे हैं एथेनॉल देगा। लेकिन अगर मैं इसको चेंज कर दूं, लेट्स से प्रोपेनल भी तो प्राइमरी अल्कोहल है, CH3 CH2 CHOH एंड देन H, ये भी तो प्राइमरी अल्कोहल है, विल इट गिव, व्हाई नॉट। CH3 इज नेक्स्ट टू CHOH नहीं है, इसमें CHOH के साथ किसको होना चाहिए, CH3 को। तो आप कहते हैं जी इसका मतलब है कि यस, प्राइमरी अल्कोहल्स डू गिव this test positive. I mean, adding iodine to the primary alcohol gives the yellow precipitate, but only one primary alcohol. जैसे aldehyde सिर्फ एक था ना, primary alcohol भी सिर्फ एक है, और वो कौन सा है, ethanol, right? Similarly, if I change this with R, armine carbon chain, it's a CH3, let's say. It's propane 2-ol. Will it give? So it means secondary alcohols will give this test positive. If I change it to CH2, CH3, will it give? If I keep the chain progressing, they will, adding iodine, they will give yellow precipitate because yes, CH3 is present to CH2. So it means in primary alcohol, there was only one, ethanol, but in secondary alcohol, this is not one. Many of them, many ketones, sorry, yes, just like ketones. So many alcohols, लेकिन still एक शर्त है कि secondary alcohol में 2-ol होना चाहिए, कि CH3 होना चाहिए ना। अब जैसे if I change it to CH2 CH3, it's still a secondary alcohol, लेकिन क्या ये टेस्ट देगा? Because now the CHOH is not next to, so it means, right? I hope you got it. So actually these are the two groups, ये वाले. So actually these are the two groups, these two, ये जो के ये देते हैं। हाँ, टर्शरी नहीं दे सकता ना। अगर मैं अल्कोहल की बात करूं, इफ आई मेक इट टर्शरी, टर्शरी क्या होता है, जिसमें CH3 ऑल साइड होती है इधर, तो उसमें से ये H चला जाता है ना, ये H भी होना चाहिए यहाँ पे। So tertiary alcohols don't give this test positive. So if I sum it up, so primarily आपको याद रखना है ये, if CH3 is next to C double bond O और CH3 is next to CHOH, then iodine डालने से क्या आ जाते हैं, yellow precipitates. But this, if you think of the groups, functional groups that give this test positive, तो आप कहते हैं okay, primary alcohol yes, but only one. That is called ethanol. Secondary alcohols, yes, most of them until CH3 is next to CHOH. Tertiary alcohols, no. Now alcohols में दो देते हैं, primary और secondary, और primary में सिर्फ एक. Come to the aldehyde. Aldehydes, only one, ethanol. Rest of the aldehydes, no. अब अगर आपने Fehling solution डाला, test positive आ गया. So it means an aldehyde. But if I ask you, okay, tell me, is it ethanol or any other aldehyde? तो फिर ये टेस्ट कर दोगे. आयोडीन डालोगे, अगर येलो प्रेसिपिटेट आए तो एथेनॉल होगा, नहीं आए तो any other aldehyde. So ketones, most of them until CH3 is next to C double bond O, right? So चार ग्रुप हो गए ना, primary alcohol, secondary alcohol, aldehyde and ketone. 4 functional groups iodine डालने से ये टेस्ट देते हैं, right? Is it clear now? Now, if I ask you now, for example, अभी मैं इसके पीछे केमिस्ट्री नहीं बता रहा, if I ask you, for example, कि ये एक कंपाउंड है, and I added I2 aqueous alkaline, what happens? Will it give the iodoform test? Will it, yes or no? Are you sure? कैसे देगा ये? Sorry? CH3 है इसमें और नेक्स्ट टू वो भी है, कहाँ है? अब कहते हैं forget about the rest of the molecule, just focus on this. Sorry, what is formed? This is CH3 and this is next to C. So as long as CH3 is present next to C double bond O, yes, banega. Okay. Now if I ask you, okay, tell me, क्यों? 2 minutes more. So if I tell you, okay, what will be the products then? Can you tell me the products? एक प्रोडक्ट जो येलो पीपीटी होते हैं वो मैंने आपको बताया हुआ है. व्हाट इज द येलो पीपीटी? आप कहते हैं ये जो CH3 था ना, that actually breaks down here and turns into CHI3. So one of the product is what? CHI3. You got it? One of the product is CHI3. The other product which you can write is, just copy this all. I'll give you the steps, but now I'm just telling you the end product. You just copy this thing again here. And put ONA in front of it. What do you have to create? ONA. क्योंकि alkaline aqueous था ना, तो क्या लगा दिया मैंने इसके साथ? ONA, right? Plus H2O. Right? So, okay, forget about the H2O at this moment. So what I'm saying, you can write the products by just looking at the reactants, right? So if somebody asks me, no, we want a full complete equation for this, कि नहीं हमें पूरी equation लिख के दें, so I can write now full equation. So the full equation says, look, this one actually reacts with how many iodine? 3I2 in the presence of what? 4 NaOH, 4 molecule of NaOH, and forms, as I said, what is the one product? CHI3. That is always there because this is the one who gives yellow precipitate, right? They don't ask you the full equation usually, but they ask you for the, and the other one is this CH3. This is the CH3 na, that turns into CHI3, which I just highlighted on the reactant side. Okay, rest of the part, break it down and put ONA in front of that. Okay, and the other product that is formed is water and sodium iodide. Okay, but they don't ask you the full equation. They usually ask you for the two main products, this one and this one, right? So, sorry. Well, just balance is 6 on this side, 3 iodine and 3 iodine, 6 on that side. Similarly, 4 Na, 4 and 3 on that side. Sorry, I just balanced it ना, because CHI3 था और NaI था, तो वो बाद में balance किया. Right now, for example, if I give you an equation, please write down. Tell me, क्या ये reaction होगा या नहीं होगा? If होगा, so you have to write the product for this. CH3 CO CH3 plus I2 plus NaOH aqueous. Can you please write the product? Please write the product and balance it. Write the product and balance it. I'll explain the steps. But ये वही है जो हाइड्रोलिसिस नहीं की थी कल, जिसमें कार्बोक्सिलिक एसिड की बजाय सॉल्ट ऑफ कार्बोक्सिलिक एसिड बनता है. Yes, फिर उसको एसिडिफाई करके वापस ले सकते हैं. So please write the product for this. And balance it, please. One product I know, CHI3, the yellow PPT. The other product is what? इधर देखो, जो भी बच जाएगा, ये वाला part is left because I have to break it from here ना. तो जो CO है उसके आगे क्या लगा देना है बच्चों? I'll explain the steps in the next class. Then you will understand. At this moment, I'm just trying to make you memorize the equation. CH3COONA. What else? Sodium iodide. And along with this, water. Now we have to balance it. Balance it. 3. 3 makes 6. 3 makes 6. That makes 4 Na. So 4 with this, yeah. How many water? Balance the water. 3H2. Similarly, this was an aldehyde, propanone. What about ethanol? पहले तो ये बताएं, ethanol देगा yellow precipitates. What will be the reaction? The one thing which you have to keep in mind, please pay attention. When it's an alcohol, na, so this part तो क्या बन जाएगा? The CH3 part turn into what? जो CH3 part होता है, वो तो किस में change हो जाता है? CHI3 में. Okay? So what is left? You have to oxidize it. क्योंकि पहले वो alcohol जो होता है वो oxidize होते हैं. So you have to remove these two hydrogen. When you remove these two hydrogen, so the product will be CHI3 plus it is left only with HC. So HCOONA plus NaI plus H2O. Now balance it out. So in other words, I'm trying to say that look at this. This is CH3CH OH now. So this, you have to remove these two hydrogens as well. Okay? And then it is left with HCO. बस उसके आगे ONA लगा देना. Okay? Now if I balance it, for example, so 4, 6, 5, 5. Here it is, the balance down. So ethanol has to oxidize as well. And then you have to put ONA in front of that. Okay, we'll continue this. We'll discuss the chemistry behind it. Thank you.